Recording has started.
So we've spent the last several classes talking about measuring devices, calipers, micrometers, and then most recently meters and gauges, dealing with figuring out what those scales stand for. For the second half of Unit 4, we're going to switch gears a little bit, and we're going to talk about algebra. And what we're going to start discussing today are things that look like this. It's called an equation, and it's called that because of course, that symbol in the middle there, the equal sign. Now, if I ask people to define what that equals sign means, a lot of people struggle to define it without using the word equals. But what it means is what is on one side has exactly the same value as what is on the other side. So that means this side, the x, has exactly the same value as the 6. In fact, we could actually think of these equations as being a balanced scale, balanced around that equal sign. Now, all equations start as a variable equals a number, or a number equals a variable, one of the two. All equations start that way with just one piece on each side, and they're built up from there. How do we build up an equation? Well, we can use any of our basic operations. We've actually seen 6 basic operations so far. They come in pairs. We've seen addition and subtraction, multiplication and division, and then we've seen a little bit of powers and roots, or exponents. We're going to stick with those first 4 for right now. But know that any of our basic operations, we could use powers and roots to build on an equation. If we were to move on, they're not part of this course, but they would be in algebra. We could use exponentials and logarithms. We could use trig functions and their inverses. Any operation, math operation, can be used to build onto these equations. Well, for right now, let's say that I'm going to add 9. So I'm going to build on by adding 9. So I have x plus 9. But remember, we said this is a balanced scale. If I put 9 on one side, the scale is going to tip unless I do exactly the same thing to the other side. So I have to add 9 to the other side of the equation as well. So 6 plus 9 is 15. So we have just built a more complex equation. From x equals 6, we've built x plus 9 equals 15. It's the same equation, it's just been built up. There have been pieces built onto it. Now, we are typically not asked to build equations. What we're asked to do is to solve equations. When we're asked to solve an equation, what we're being asked to do is take it apart and get it back to that form of a variable equals a number. Back to where it started, in other words. So here, this equation was built by adding 9. To take it apart, we use the inverse pairs of operations. Remember, we said addition and subtraction went together, because if we add something and then turn around and subtract the same thing, we get right back to where we started. So this equation was built by adding 9. We take it apart by subtracting 9. Subtracting 9 removes the 9 on the left side there. But remember this idea of the balanced scale, we had to do the exact same thing to both sides. We subtracted 9 from the left side. We have to subtract 9 from the right side of the equation. 15 minus 9 is 6. And that gets us back to that form of a variable equals a number. That's back to where this equation started, x equals 6. Now here, we built the equation, or at least you watched it get built, so we knew how to take it apart. Usually, the tricky part with these equations is figuring out how they were built. So if I have that 45 equals 5x, the way I figure out how this is built is I find my equal sign. It's right there. Then I find which side of the equation my variable's on. It's over here on the right side. Then I ask myself, what is keeping the variable from being by itself? What's keeping it from being alone on that side of the equation? In this case, it's the 5. So then we ask, what operation is attaching the 5 to the x? It's being multiplied. So that tells us that when this equation was built, what was done to x was it was multiplied by 5. So how are we going to take it apart? Well, the opposite of multiplying by 5 is dividing by 5. That'll cancel that out. We have to divide by 5 on the other side as well. So 45 divided by 5 gives us 9. On the right side, 5x divided by 5, like we said, the 5's cancel out, and that's just x. 9 equals x, or x equals 9. We might have something like 3x minus 7 equals 17. To solve that, obviously more than one thing happened here. We find our equal sign. We identify which side the variable's on. It's over here on the left side. Now there are two things that are keeping x from being alone. We have the 3 and the 7. The 3 was multiplied and the 7 has been subtracted. So if we ask ourselves what was done to x to build this equation, what had to happen first, order of operations, says we would multiply before we would subtract. So the first thing here, x was multiplied by 3. Then the 7 was subtracted from it. Now, if you think about putting together a toy or a model or piece of furniture, whatever, you've just finished putting it together. You've just put on the last piece. If you have to take it apart again, the first piece you're going to take off is that last piece you put on. Same with an equation. When we go to take it apart, the first piece we take off is going to be the last piece we put on. The last piece put on here was subtracting 7, so we're going to take that off first. The opposite of subtracting 7 is adding 7. So that'll remove that subtracting 7. Remembering that we have to do exactly the same thing to the other side of the equation. So on the left side, we've canceled out the minus 7, so we just have 3x. Equals, on the right side, 17 plus 7 is 24. Now we need to get rid of the 3. The 3 is multiplying x, so we'll get rid of it by dividing by 3. Remembering to do the exact same thing to the other side. So 3x divided by 3, the 3's just cancel out, leaving us with x. 24 divided by 3 gives us 8. So x equals 8. Now, if we're not sure of ourselves here, we can always go back to the original equation and plug in that number and make sure we get a balanced scale. Make sure we get the same value on each side of the equal sign. So if x equals 8, 3x minus 7 becomes 3 times 8 minus 7. and then equals 17. Now the 17 here, where'd I go? Get back here. The 17 here, there's nothing to do with that. So we have 17 on the right side. Left side, we have some operations to do. So we have to do order of operations to see what we get. We would multiply first. 3 times 8 is 24. And then subtract 7. 24 minus 7 is 17. So we do get 17 on both sides of that equation. So we might have an equation like this. 19 equals 2y plus 5. We find our equal sign, and we find what side the variable is on. What's keeping y from being by itself is the 2 and the 5. So to figure out what was done to y to build this equation, we would multiply first, so that it was multiplied by 2, then the 5 was added to it. So to take this apart, remember we take off the last piece first. Adding 5 is the last piece that was put on. To take that off, the opposite of adding 5 is subtracting 5. So we'll subtract 5 on the left side, and we subtract 5 on the right side to cancel out the adding 5. 19 minus 5 is 14, equals, on the right side, what's left is the 2y. Now to get rid of the 2, it's multiplying y, so we'll divide by 2. 14 divided by 2 is 7. On the right side, 2y divided by 2, the 2's cancel out, and we just have y. 7 equals y. Once again, we should double check that. So 19 equals 2y plus 5 becomes 2 times 7 plus 5. 19, there's nothing to combine with that, so that's just going to stay 19. On the right side, we'll do order of operations. 2 times 7 is 14, and then 14 plus 5 is 19. So 19 equals 19. We get the same value on both sides of the equation. That confirms our solution of 7 equals y. I'm going to have you guys try one in your notes. 5x minus 3 equals 47. Solve that for me quick. We'll go over it in about a minute. So, we find our equal sign, we find where the variable is. What was done to x to build this is it was multiplied by 5, and then 3 was subtracted from it. Now, I'm not going to keep doing this. It's probably the last time you'll see me do this, except for maybe during review later on. So to take this apart, the first thing we have to do is remove the subtracting 3. We will remove that by adding 3. So on the left side, we've canceled out the minus 3, leaving us with just 5x equals. On the right side, 47 plus 3 is 50. Now, x is multiplied by 5, so we have to get rid of it. The opposite of multiplying by 5 is dividing by 5. So we divide both sides of the equation by 5. So that 5 cancels out. We're left with just x here on the left side. 50 divided by 5 is 10. So x equals 10. Let's double check this by plugging it back in. 5x becomes 5 times 10 minus 3 equals 47. So again, the 47, there's nothing to do there, so that's just going to stay 47. On the other side here, on the left side, we're going to do order of operations. We multiply first. 5 times 10 is 50. 50 minus 3 is 47. So we have the same number on both sides. That confirms x equals 10 is a valid solution to that equation. We can run into things like this. 5x minus 7 minus 2x equals 11. When we go to find our equal sign here, it's right there. When we go to identify where the variable is, we notice that the variable appears twice. On the left side there, we have 5x and a negative 2x. Well, if we continue with this idea of a balanced scale, where we balance around the equal sign, the 5x and the negative 2x are on the same side of that scale. So that means I can push them together and make one big pile of x's, and it doesn't affect the way the scale balances. 5x plus negative 2x, 5 and a negative 2 makes a positive 3, x. And we have the negative 7 is still there, equals 11 on the other side. So we combine the 5x and the negative 2x, and now we have an equation that looks like the ones we've been solving. So sometimes before we solve, one of the things we have to do is to combine what we can on each side of the equation. In this case, that was combining the 5x and the negative 2x. Now we're going to go ahead and solve this. X was multiplied by 3, then the 7 was subtracted. So we're going to add the 7, cancels out the minus 7, leaving us with the 3x. On the other side, 11 plus 7 is 18. Then we'll divide by 3. Cancels out the 3, leaving us with just x. 18 divided by 3 is 6, so x equals 6. Now we can still go back, and we should go all the way back to the original equation in case we made any mistakes along the way, and double check to make sure that x equals 6 works in that equation. So 5x becomes 5 times 6, minus 7 minus 2x becomes minus 2 times 6, equals 11. Now there's nothing to do with that 11. It's all by itself on the right side. On the left side, we're going to do order of operations. So we have multiplication. We'll go left to right. We got 5 times 6 is 30. We have 2 times 6 is 12. Now we have addition and subtraction going, or just subtraction, I should say. We'll go left to right. 30 minus 7 is 23. And 23 minus 12 is 11. So we get 11 on both sides. So that confirms that x equals 6 is a valid solution to that equation. Well, a slightly different situation than what I just had is this one. So here we find our equal sign. It's right there. We go to identify where our variable is, and we find that the variable is on each side. Thinking of that balanced scale notion again, balancing around the equal sign, we cannot just push the 7x and the 5x together because they're on opposite sides of our scale. They're not with each other. If we try to just combine them and push them together, we're going to change how this scale balances. So when the variables appear on opposite sides, we have to get rid of one of them. What we're going to do is we're going to find the smaller one, in this case the 5x, and do its opposite. It's a positive 5x, so to get rid of it, we subtract 5x. That will remove it. Now we subtracted 5x from the right side of this scale, from this equation. We have to subtract 5x from the other side. Now it has a name of x, so the only thing we can take it away from is other things with the name of x. So we would have to subtract it from the 7x. So 7x minus 5x is 2x. The positive 5 is still on the left side there, so plus 5 equals. So on the right side, we remove the 5x, so it's gone. So all that's left on the right side is 13. Now, this is in that form that we've solved before. We'll subtract 5 from both sides. On the left side, the 5 is gone, so we just have the 2x. On the right side, 13 minus 5 is 8. Then we divide by 2. That cancels out the 2, leaving us with just x. 8 divided by 2 is 4. So we get x equals 4. Now we should go back and substitute in to make sure that x equals 4. It gives us the same value on each side. So on the left side, 7x plus 5 becomes 7 times 4 plus 5 equals. On the right side, 5x plus 13 becomes 5 times 4 plus 13. And now we have to do order of operations on both sides. So on the left side, we'll multiply first. 7 times 4 is 28. 28 plus 5 is 33. On the right side, we have 5 times 4 is 20. 20 plus 13 is 33. So we have 33 equals 33. That affirms that x equals 4 is a solution, is a valid solution to that equation. So this gives us a second thing that we have to look for before we solve. So when solving equations, the first thing we have to do is what we did before, combine what we can on either side. And now this gave us the second thing we need to do. That is make sure the variable is on only one side. Then we can solve. But only if those first two pieces are complete can we then solve the equation. In other words, solving means take it apart. So we might have an equation like 5x minus 3 plus 4x equals 6x plus 36. So here, remember that first step is to combine what we can on either side of the equation. On the left side over here, we can combine 5x and 4x. They're both positive. The 5 plus 4 is 9, so that is 9x. We still have the minus 3. That hasn't gone away, and we haven't combined it with anything. So the left side combines to make 9x minus 3. Right side, there's nothing to combine. We just have 6x plus 36. So we'll just rewrite that. Nothing to do there. Now, the second thing we have to do is make sure the variable's on only one side. We have 9x and 6x. We're going to get rid of the smaller one, which is the 6x. Since it is a positive 6x, we're going to get rid of it by subtracting 6x. That makes that go away. Now we have to subtract 6x from the other side of the equation as well. We can only take x's away from other x's. So we'll subtract the 6x from the 9x. So now 9x minus 6x is 3x. We still have the minus 3 there, haven't done anything with it. On the right side, we just have the 36. The 6x is gone. Now we've combined what we can on both sides. We've made sure the variable is on just one side. Now we can solve it. Now we can take it apart. Here, x has been multiplied by 3, and then 3 has been subtracted from it. So to take it apart, we're going to add 3. That removes the minus 3, giving us 3x. Remembering we have to add 3 to the other side as well. 36 plus 3 is 39. And then finally, we have to divide by 3 to get rid of the multiplying by 3. So we divide by 3, that cancels that out. We have x equals 39 divided by 3 is 13. X equals 13. To verify that that works, that that's a solution, we go back to the original equation, and we're going to replace x with 13. So 5x is 5 times 13 minus 3 plus 4x is 4 times 13 equals 6x will be 6 times 13 and plus 36. So now we're going to do our order of operations on each side. I'm going to start out with just the left side over here. We have multiplication, a couple multiplications, so we'll go left to right. 5 times 13 is 65. And then we have 4 times 13, which is 52. Now we have addition and subtraction, so we're going to go left to right. 65 minus 3 is 62. And finally, 62 plus 52 is 114. On the right side, well, we have 6 times 13, which is 78. 78 plus 36 is 114. So we get 114 on both sides, the same value on each side of the equation, which confirms that x equals 13 is a valid solution to that equation. So we can look at an equation like this. Now remember, step 1 is to combine whatever we can combine on either side. On the left side over here, we can combine the 4x and the negative 2x. 4 and negative 2 make 2x. We still have the plus 3, so we're going to keep that there. That's all we can combine on that left side. On the right side, we have 5 and negative 9, which makes a negative 4. And then just the positive 3x. So we have combined everything we can combine on either side. Now, we have to make sure that the variable is on only one side. We'll only have 2x on the left side, 3x on the right side. We need to get rid of 1. 2x is the smaller one, so that's the one I'm going to get rid of. It's positive, so I'm going to get rid of it by subtracting it. 2x minus 2x is 0. It cancels out. That'll leave us just 3 on that left side. Now we also have to take 2x away from the right side. The only place we can take it away from is other x's, so we'll take it from the 3x. So the negative 4 hasn't changed. 3x minus 2x, well, 3 minus 2 is 1x. Now, we don't need the 1 there. We can just write that as 3 equals negative 4 plus x. We don't need the 1 there at all. So now to solve this, we have it in that form where we've combined everything we can and the variable's on only one side. So we can go ahead and take this apart. All that has happened to x here, it doesn't look like it's subtraction, but it is. 4 has been subtracted from, we either think of it as 4 has been subtracted from x, or we can think of it as a negative 4 has been added to x. It's the same thing. We remember when we did our negatives, our integers, adding a negative 4 and subtracting a 4 are the same thing mathematically. But it's easier for us to think of this as being subtracting 4, so that to solve it, we're going to add 4 to remove that minus 4, making sure we add 4 to the other side. 3 plus 4 is 7 equals, on the right side, the 4's have canceled out, leaving us with just x. Since it was a 1x or just x, there's nothing to divide by. We have 7 equals x. So now, system's going a little nuts here on me. We should go back and check to make sure that answer works. So we'll put 7 in for x. 4x becomes 4 times 7. Plus 3 minus 2x is 2 times 7. Equals 5 plus 3x becomes 3 times 7 minus 9. So we'll do our order of operations on the left side first. There's a couple multiplications. We're going to go left to right. 4 times 7 is 28. The 2 times 7 is 14. Now all that's left is addition and subtraction. We'll go left to right. 28 plus 3 is 31. And 31 minus 14 is 17. So on the left side, we get 17. Let's see what we get on the right side. So we've got multiplication. 3 times 7 is 21. All that's left now is addition and subtraction, so we'll go left to right. 5 plus 21 is 26. And 26 minus 9 is 17. We get 17 on both sides, so that confirms that x equals 7 is a valid solution to that equation. Really, the only way to get good at these is to practice. So I wanted to make sure I gave you time here to practice. Our homework here today . Out of the book, page 249, exercise 6.1. Try to make that legible. Problems 1 through 59, the odds are the basic equations. And then page 251, that's exercise 6.2, 1 through 29, the odds are the equations where you'll have to either combine or get the variable on one side before you can solve. So we have about a little over 14 minutes left. We'll give you that time to get started on these. I'll be on the network here to answer any questions. Otherwise, if you want to get going, you are free to go.